Hey everyone, and welcome. So today we're going to jump into the world of OpenStack networking. If you've ever wondered how a massive cloud platform keeps all its data flowing without turning into a giant tangled mess, well, you are in exactly the right place. We're going to break down the different types of network traffic and see why separating them is so important for a cloud that's both stable and secure. Let's get right into it. All right, here's what we've got on tap. We'll kick things off with a big why, as in, why even bother separating traffic in the first place? Then we'll walk through the four main networks you'll find in OpenStack. And to wrap it all up, we'll connect the dots and see how your apps actually talk to the outside world. So first up, let's look at the big picture. In a powerful cloud environment like OpenStack, there's just a lot going on. All at once. You've got the system talking to itself, you're talking to the system, and your own applications are talking to each other. It's a seriously busy place. And that brings up a really good question. Why can't we just have all this traffic use the same road? One giant network for everything. I mean, it seems like that would be way simpler, right? Well, let's dig into why that's actually a really bad idea. Well, when you throw all your traffic onto one network, you get the problem you see right here. It's like a building with only one hallway for everybody. It is total chaos. You get major security risks and some epic traffic jams. The solution is to create these specialized pathways. This gives us the security and the organization we need to keep the cloud running smoothly. To make this all super clear, we're going to use an analogy for the rest of this explainer. I want you to picture your OpenStack cloud as a smart, secure, high-tech office building. Every network we talk about is going to be a different part of this building. Okay, let's start with our first network. In our building analogy, this is like these staff-only corridors. The places where all the behind-the-scenes magic happens. So the management network is basically the cloud's internal nervous system. Just think of it as those secure, staff-only hallways that nobody else can access. Its whole purpose is to let all the internal systems communicate with each other privately to keep the entire operation running. Yep, this network is all about that behind-the-scenes chatter. It's how the core components, the real gears of the system, talk to things like the central database and the message queue. And keeping this traffic completely separate, totally hidden, that is absolutely crucial for security. All right, time for a quick pop quiz. Which network handles all that internal behind-the-scenes chatter between system components? You got it, it's the management network. Okay, let's move on. If the management network was the hidden staff corridors, then the API network, well, that's the grand, public-facing main lobby. The API network is basically the front door. Just like when you walk into a building's main lobby, this is where you, the user, go to interact with the cloud. Its job is to expose all the cloud services so you can make requests, kind of like asking the reception desk for help or information. So the most important thing to remember here is that this is your entry point. All the key OpenStack services are listening on this network, just waiting for your instructions. So whether you need to prove who you are or ask for a new server, your command comes right through this front door. Okay, let's test that out. If you wanted to ask the cloud to fire up a brand new virtual machine, which network would your request go through? Yep, you got it, the API network. All right, so we've covered how the building runs and how you get in the front door. Now, let's head on up to the private office floors. This is where the actual work gets done. The guest network is like the private, secure floors that different companies rent out. This isn't for managing the cloud itself. This is for the traffic that's created by your applications running inside the cloud. And every tenant gets their own completely isolated space. This network is what carries all the data zipping back and forth between your virtual machines. So if you have a web server that needs to talk to its database, that conversation happens right here, on your private floor. And the traffic for one tenant is completely walled off from another. This is really the heart of multi-tenancy. Your office floor is locked and nobody else can get in. So, quick review on that one. The network that carries traffic between your own virtual machines is called the guest network. Perfect. We have one last network to check out. Our building is humming along and people are busy working in their offices. But what happens when they need to connect to the outside world? That is exactly where the external network comes in. In our analogy, this is just the system of roads and highways that connects our building to the rest of the world. Its whole reason for being is to provide a connection to the internet. You can think of this network as the on-ramp and the off-ramp for all your cloud's data. It's what lets your applications get out to the internet, but just as importantly, it's the source for something called floating IPs. A floating IP is like a public street address for your office. It's what allows the outside world to find and connect to your applications. Okay, final quiz question for this section. Which network is the source for those floating IPs that let your apps be reached from the internet? Of course, it's the external network. Great job. So now that we know all the different parts of our smart building, let's watch them all work together. We're going to follow a single piece of data as it leaves one of your apps and makes its way out to the internet. It's a pretty simple 4-step journey. First, your app sends out some data from its office, and that's all happening on the guest network. Next, that data goes through the building's router, which is kind of like the central mailroom. From there, the router sends it out onto the main road. That's the external network. And just like that, your data is out on the internet. And this diagram right here shows you the more technical view of that same trip. So let's connect the dots. Here's our virtual machine running on what's called a tenant network. That's our guest network, our private office. It sends its data through this Neutron router. That's our mailroom. And then the router passes it to the provider network, which is our external network, the main road to the internet. See? It's the same exact path, just with the official names. So really, the big takeaway today is this. Separating these 4 types of traffic, management, API, guest, and external, isn't just some random technical detail. It's the fundamental blueprint that keeps a cloud secure, organized, and running smoothly. Each network has one clear, distinct job to do. And there you have it, a quick guide to network traffic in OpenStack. Now that you know the blueprint of our smart building, what part of the cloud are you curious about next? Let us know. Thanks for hanging out with me, and I'll catch you in the next one.